All right, tonight what we're going to be talking about is molarity. And molarity is just a form of concentration measured by the amount of solute for a liter of solution. It's very similar to density, but the difference is that for density, it's the amount of mass, such as in grams, for every liter, okay? Whereas molarity is the amount. So how do we measure amount in chemistry or science? It is through moles. So it's the amount of particles, how many little particles do we have in a given solution. So therefore, if you have a solution that has a higher number, such as a 3 molar solution, what you are saying is that you have 3 moles of something for every 1 liter of solution. Therefore, if I compared that to something with, let's say, a 2 molar solution, that would be 2 moles of particles for every 1 liter of solution. Therefore, the higher the number, the higher the concentration, or the stronger the molarity. As far as terminology goes, whenever you assign the molarity with a number, such as 3, it becomes the word molar. So 3M is known as a 3 molar solution. When there is no number assigned to it, such as what is the molarity, notice that I have no assignment of number to that, the word molarity, or the M becomes molarity. Okay, so if it has a number, we say the word molar. If it is, if we don't have the M, if we don't have a number, then it's just known as molarity. Okay, so it's just a little kind of phonetics type of thing. And also notice that molarity is a capital M. Okay, so we capitalize that M. That is to differentiate between meters, which is lowercase m, and italicized m, which is molality, which is something we are not going to be talking about here. All right, so there are some formulas that you're going to need to be able to use, and right here is the formula for molarity, and what it tells you is that molarity symbol is capital M, or you could write moles over liters. Typically in this class we will absolutely be writing capital M. It's a lot shorter. And what that is that the formula for molarity is the amount of moles of solute, okay, so what you are, the solid particle that you are dissolving, per liter of solution. So the entire solution, how much volume is it? Okay? We are going to introduce you to a triangle, and this triangle is a great way to be able to utilize the formula that's written above. All you have to do to use this formula, okay, because it rearranges it algebraically, is whatever I ask you to solve for, you cover up with your finger, and then you do what the math tells you to. So if I ask you to solve for molarity, I'm going to cover up the M, and it tells me to do moles divided by liters. Okay, now let's say I asked you to solve for liters. So I'd cover up liters, and now I'm going to do moles divided by molarity. And then the last one, whoops, I need to erase that. The last one is if I ask you to solve for moles, you cover up moles, and what does it tell you to do? Molarity times the liters. Okay, so the triangle is really nice because it rearranges the formula written above easily without you actually having to rearrange it. Now, it is really important for this unit especially that you understand that moles is the amount of little particles, and it is not the same thing as molarity, which is capital M. Moles is abbreviated MOL. It's the amount of particles. Molarity is written as capital M. It is the concentration. So it's like saying something as its density is 2 grams per liter, or its mass is 2 grams. Those are two different things. So if I said it has 3 moles, or its molarity is 3, then therefore they are saying very different things. All right. The other formula that you're going to be using is if I ask you to, or I give you grams, okay? The triangle you use if I ask or give you moles. The grams formula is if I ask you or give you grams, which is very, very common in this class. So how to do solve for molarity or liters or grams. In this case, you are going to take grams divided by the molar mass of whatever substance we're talking about, and that is going to equal that capital M, which is molarity, times liters. Notice for both of these formulas, your unit is in liters. So for when you are dealing with molarity, you are going to be needing to use liters. All right, so let's try to do some of these problems. A sample contains 2.3 moles of sucrose was mixed in water. So basically sucrose is sugar. So I had 2.3 moles of sucrose, and then I completely dissolved it, and my total volume of solution is 1.35. What is the molarity of the solution? So we're going to use, in this case, the triangle. Why the triangle? Because I give you moles. Whenever I ask or give you moles, you're going to use the triangle. Whenever I ask or give you grams, you are going to use the grams formula. So in this case, I give you moles, which is this guy, and I give you liters, which is this guy. So I'm going to take my moles divided by my liters, and that equals my molarity. So I'm going to take molarity equals 2.3 moles divided by my 1.35 liters, and that rounded to the correct number of sig figs is 1.7 molar. Once again, remember I said I assigned it with a number, so now I say molar. Okay, example number 2. What is the molarity of 245 grams of H2SO4 dissolved in 150 milliliters? So for this case, I have a lot going on. I'm going to first figure out which formula out of the molarity formulas that I'm going to need to use, and that would be the grams one. Why? Because I gave you grams. So the grams formula is grams over molar mass equals molarity times liters. So in this case, my grams is 245, so I'm going to put in 245 grams divided by my molar mass. So I need to figure out the molar mass of H2SO4, which is 2 times 1 plus 32.1 plus 16 times 4. So when I multiply that out, I get 98.1. So my molar mass is 98.1 grams. That is equal to my molarity, which is what I'm trying to solve for, so I'm going to put a capital M there. And that is times liters. So unfortunately, I give you the volume in milliliters, so I'm going to need to convert. So for every 150 milliliters, I need to figure out how many liters that is. I don't know that exactly, but I do know that 1,000 milliliters equals 1 liter, which means that I end up with 0.150 liters. So now I'm going to plug that number into my equation, and so it's molarity times 0.150, and now when I multiply that out, I get 1 point, and solve for M, I get 1.7 molar. Alright, the next one is how many grams of H2SO4 would be needed to make 750 milliliters of a 2 molar solution. So once again, I'm going to use the grams formula, which is grams over molar mass equals molarity times liters, and the reason why is because I'm asking for grams. So in this case, this is the one that I'm asking for. So I'm going to have G over my molar mass, which is still 98.1. That equals my molarity, which is 2.0 times my liters. Now, you can set up the proportions, or if your teacher allows, you can just move it over 3 decimals. So instead of 750, it would be 0.750 liters. Okay? And so when we cross multiply that, I get 150 grams, rounded to the correct number of sig figs. Alright, hopefully you have a basic understanding of molarity, and we're going to be practicing more of these in class.